In this video, I want to briefly talk to you about how you can use definite integrals to calculate the area between two curves. Well, first let's refresh our memories a little bit. We know that the definite integral, provided that our function is greater than or equal to 0, is defined as the area under the curve of the function f of x between a and b. So if I found the area of that region there underneath our function, then this by definition is the integral from a to b of f of x dx. And if you really look at this, if this is the x-axis here and this is a y-axis, this is like finding the area between the function f of x and 0, right? Because the x-axis is really y equals 0, and so it's the same thing as finding the area between this function up here, f of x, and this function down here, 0. So that's the most basic case. So suppose I had something that looked like this. I had function on the top, we'll use some colors here, say f of x, and then another function below, let's say g of x, and I wanted to find the area between the two curves from here to here. Maybe we'll call that A, we'll call that B. So the area I'm trying to find is this area in this region right in here, right? That's the area I'm trying to find. So let's think about this. It's almost like saying, well, what if I found the area underneath the red function, which would be all of that, and then I found the area underneath the blue function, which would be all of this, and I subtracted those two values. If I subtracted those two values, then what I'd be left with is this stuff in the orange, right? All of that in there. And so it looks like if I knew the areas of all these functions, it would be true that the area between f of x and g of x, I'm talking about areas, would be something like the area under the curve f minus the area under the curve g. So this might help me understand a little bit better how I can come up with the formula, because I know how to calculate the area of f, provided that the functions are above the x-axis. If they're below, we know that's a sine area, but both of them are above the x-axis. So this would be the integral from a to b of f of x dx minus the integral from a to b of g of x dx. And so I can put those two integrals together. And so I have this. I can actually put those together. Just clean this up a little bit here. Because this is the same thing as the integral from a to b of f of x minus g of x dx. So here's the formula that I can use now to find the area between two curves. And there's really only one rule of thumb. We just always know that f of x, as the formula is written, is let's say above, and g of x, as that formula is written, is always below. So in any problem where I'm trying to find the area underneath the curve or in between two functions, the first thing I need to do is just identify the function that's above and below, then find the difference of those two functions and integrate them from a to b. So here's an example. What if I wanted to find the area between, let's say, f of x equals x squared and f of x is equal to x on the interval 0 to 1. Well, the first thing I need to do is I need to graph those two functions. So one of them is a parabola. Looks something like this. See if I can get that in there. And then the other one is going to be the straight line. That will look something like this. And they will have intersection points down here at 0. And then over here at x equals 1. So the region that I'm trying to find the area of is this orange region in here. Of course, that purple function is x. I'm sorry, that's x. And the red function is x squared. So the top function is x, and the bottom function is x squared. So from what we've learned, we know that to find the area in between, we need to integrate from a to b. So that's going to be the integral from 0 to 1. The top function is x minus the bottom function, which is x squared, and that's dx. So if we do this definite integral, that should give us the area. So let's calculate that. And so we'll integrate these pieces. So the antiderivative of x is x squared over 2 minus the antiderivative of x squared is x cubed over 3. That needs to be evaluated between 0 and 1. Plugging in the upper limit, we get 1/2 minus 1/3. Minus, when we plug in the lower limit, we just get 0. So this is equal to 3/6 minus 2/6, which is 1/6. So the area between those two curves is 1/6, and if you like, we can say units square.